have a daily concept check today. So from the most important parts or topics that we studied in chapter 4 so far. I created a function f of x equals e to 3x plus natural log of x squared plus 2x, and I want us to determine its derivative, and I want us to determine its differential. Can anyone help? Don't be afraid to be wrong. Yes, I'm ready. So f prime of x, yes, is 3e to 3x, awesome, plus, awesome.
Over x squared plus 2x times 2x plus 2.
Excellent. What was that?
1.
Thank you. This is it. Perfect. Now I want to determine the differential. How do I determine the differential?
For e to the 3x, it would be e to the 3x over 3.
Careful, careful. What do we call the differential? What is the formula for the differential? Let's write the differential, the formula for the differential here. What is the notation? And what is the formula? And then we apply it here for this function. We find the differential of this function. But first, let's try the formula. Anyone would like to give us the formula?
Well, I thought it was just say mx equals 1 over e to the mx, so
the function is not important. We want to write the formula for the differential of any function. Forget about this function. We want to write the formula. Yes, f prime of x dx. So please remember, thank you so much. That was Sammy?
Yeah.
Thank you. So please understand this formula. This is the formula for the differential. The differential of a function is dy. And the formula is f prime of x dx. Now we want to apply this formula for this function. What will you say? I have to write dy. Yes, 3e to 3x plus 2x plus 2 over x squared plus 2x. This is this piece times dx. So please understand the difference between these two. And you can say, why is it so important? Okay, here is why it's so important. This is the differential. F times dx. Yes, it's f prime. This is the differential. So that's the reason why we need to understand the difference between the derivative of f of x, which is this, and the differential of f of x, which is this. And this is the notation. So this is important for what follows in this chapter. Yes, go ahead. Sorry.
So when you ask for the differential function, you want me to state dy first?
Exactly.
Oh, okay.
Excellent. Yes.
I was just giving you the differential of e to 3x.
Yes. So you're right. This is a function, but this is an equation. So when we talk about the derivative, it's just the rate of change of that function. But when we talk about the differential, we have to write an equation. The left-hand side is dy, the right-hand side is f prime of x dx. Awesome. Good. The most general antiderivative is of functions with the same derivative function. family. So it's not one function. The most general antiderivative is infinitely many functions. We call it a family of functions. Infinitely many functions with the same derivative. How do we write in symbols the most general antiderivative? And how is this called? And what do I have here? This is called the what is it called? This is like a foreign language. We need to know what this symbol means. What is this symbol? Yes, but it's not the definite because it does not have limits of integration. It's the indefinite integral. Of course, from the differential, f of x dx. And the answer has to be the most general antiderivative plus a constant c. So the most general antiderivative, which is this plus c, right, is the indefinite integral from f of x dx. You can put f prime, it doesn't matter, but it's a function, any function. So the integral from f of x dx is the most general antiderivative of this function. Now, let's talk about the exact area under the graph of a function on the interval a comma b. How do I write that? I'm talking about the exact, and I'm talking about the number. How do I write that? How is this called now? And how do I write it? This was the most general antiderivative, which is the indefinite integral. But now we're looking at the exact area. How do I write this? It's the same. Still f of x dx, but it's not called the indefinite. But what is it called? Yes, this is the definite integral. So this was the indefinite because it's the most general antiderivative, but this is the definite. It starts definitely here and it ends definitely here, if you want to remember it like that. The definite integral from a to b from f of x dx is still a sum. Both of them are sums, okay? Just it's same symbol. And how do I determine this? And it's called the fundamental theorem of calculus. How do I determine this? So I have to write f of x, uppercase f of x. I have to put a vertical bar from a to b, and what do I get as the answer? Which is the fundamental theorem of calculus. How do I write it?
Equals f parentheses b.
F of b minus,
F of a.
that's it. And it must be a number. The answer is a number. Okay, these are the most important concepts here in this chapter. The derivative, the differential, what is the most general antiderivative, which is a family of functions with the same derivative. How do I calculate that? With the indefinite integral, and I get f of x plus c, which is a family of functions. Many, infinitely many functions whose derivative is this. Because that's how we determine it, right? If this is x, I ask you which function we differentiate to get x, and you say x squared over 2. So this function prime is this. But now when we calculate the area on the graph, the exact area, we are using the same symbol, but this is not going to be a function, it's going to be, or a family of functions, but a number. The definite integral from a to b from f of x dx, which is the definite integral. And now we also know how to calculate the definite integral, again, assuming we can determine this function. I can show you many examples in which we will not be able to determine that function. Here's one, and we will not have to worry about it. Let's say the integral from 1 to 2 from e to x squared dx. No human being can find the antiderivative of this. We cannot find f of x to plug in 1 to 2. Plug in 2 minus f of 1. We cannot. A computer can, the software can, but not us. Even the calculator will be able to give us a number, but we cannot find this function. So that's why we use the approximations, leftmost point, rightmost point, and other methods. Okay. Now I'd like to go back to page 414. I hope I'm not logged out. Okay. So I'd like to look at, let's say problem 55. I don't remember doing 55. And I'd like us to look at the word problem. 55 is from 1 to e, the definite integral from y to e from x plus 1 over x dx. Okay. So in this question, it says evaluate. So we have to find the number. Yes, you can say plug it in the calculator, yes, but that's not the point here. The point is to understand how the fundamental theorem of calculus is applied in this case. So like before, I'm asking myself, which function prime is x? Which function prime is x? I hope you notice that I'm waiting for an answer. I'm not moving on before you say something. So we cannot say that we're going too fast. Can anyone help the function prime that is x? Please.
X squared over 2.
Thank you. Now, which function prime is 1 over x? Of course, I will write 1 to e. Which function I differentiate to get 1 over x? Very good. But remember, this time we have to write the absolute value. Thank you. So let me write the formula one more time for everyone here. The integral from 1 over x dx is natural log of the absolute value of x plus a constant c. Now, because e and 1 are positive numbers, there is no need for the absolute value, but initially I have to write it. So now I have to plug in e everywhere. E squared over 2 plus natural log e minus, open parentheses so you don't make an error. When you plug in 1 half minus, not minus, but plus, sorry, natural log 1. Anyone remembers how much is natural log e, and anyone remembers how much is natural log 1? Say it again. Anyone? Anyone remembers natural log e? Thank you. Anyone remembers natural log 1? Yes, thank you very much. This is 0. So 1 minus 1 half is 1 half, so the answer is e squared over 2 plus 1 half. You can write it as e squared plus 1 over 2, or like this, it's fine, either way. So now let's see how we apply definite integrals, which we already did. Let's take a look at a word problem. Increasing total cost. Kitchens to Please Contracting determines that the marginal cost in dollars per square foot of installing X square feet of kitchen countertop is given by, look at that. They came up with a function. Good for them. So this is 61. So they're giving us C prime of X equals 4x to 1/3. Find the total cost of installing 50 square feet of countertop. Total cost for 50 square feet. This is the marginal cost. They want us to find the total cost. So this is the total cost. Function. I don't have it. I'm only given the marginal cost. How do I find the total cost? Any ideas?
Take the antiderivative of that.
True, true, awesome, perfect. But I prefer the integral from 0 to 50, from nothing to installing 50 square feet, from what? And you have to say from the differential. What is the differential? It's all based on the same formula. Yes? Yes? That's it. Because it's C prime of x dx. Awesome. So this is C prime of x dx. Excellent. That's why we need to understand the difference between the derivative and the differential. Perfect. 4 is a constant, it's a factor, stays outside. Now I need to determine the function whose derivative is this. And then just plug in 0 to 50. I need this function. This function, when I differentiate it, I get x to 1/3.
4 times 3 or 4x to 4 over 3.
Yes, we are adding 1 and we just simply copy that number. That's it. So it's x to 1/3 plus 1, which is 4/3. And all we have to do, no calculations are required, just divide by that result. Because this is a polynomial, so to speak. It's the power rule. Good, I have to flip into 3/4 and I simplify. So this is 3 x to 4/3 from 0 to 50. All I have to do in this case, plug in 50, because when I plug in 0, I get 0. So I can omit this. But remember, if this has an e in it, you have to plug in 0, because e to 0 is not 0, it's 1. But because of this form, when you plug in 0, you get 0. So this is 3 times 50 raised to 4/3. I have no idea what that is, but I'm going to use the calculator. Where are you guys? I see you here, here. Okay, so I have 4, and I need to multiply by 50, and the power is 4/3. And close. Whatever that is, 736.81. And this is the total cost, so it must be in dollars. It's not marginal cost. Now, in order to double check my work, I will do this to 50. I will put in the function as 4 times x to power 1/3. Don't forget the dx, because you need the differential. And when I click enter, I have to get the same number. If I don't, I'm in trouble. I have to start. Look how long it takes. Really? Okay.
The power is not so 4/3. Needs to be to the 4/3. You have that to 1/3. Is that
Yes, but because that's the function. because that's the function. So the integral from 0 to 50, that's the original problem, right? X to 1/3 dx. Okay, so where's my calculator? Here it is. I don't trust that software anymore, so it's 50 and the power is 4/3.
When I did it on my way,
Yes, I got 552. Yes,
yeah, that's what I got too.
unbelievable. 552.60. Let's take a look again.
That's what I got as well.
Yeah, what is going on? So maybe it didn't like the fact that I didn't put power or something. Let me see. Let me do it in a different way. What is going on? Oh, because I put 4 instead of 3. I got it. I copied 4 instead of 3. My error. Yes. Okay, I put 4 instead of 3. It was 3 times 50 to the power 4/3. Okay, good. Excellent. Let me start a new